Hello everyone. So today I am going to start factorization. Factorization, before we go into the topic, let us build up the concept about what is polynomial. Polynomial means it is an algebraic expression. If I define a polynomial, so it is an algebraic expression. So let me start with the general form of a polynomial. So general form of a polynomial is a0 x raised to n plus a1 x raised to n minus 1 plus a raised to n. So this is a polynomial where a0 not equal to 0. What will happen if a0 will become 0? The degree of the polynomial reduced to n minus 1. So this is a polynomial of degree n. This is a polynomial of degree n. And a0, a1, an all r belongs to R. And what about n? N must be a non-negative integer. N must be non-negative integer. So this is called a polynomial. Generally in maths, this is a polynomial containing the variable x. So we represent it as a f of x. F of x. Suppose if it is a variable y, so we can write f of y. In place of f of x, we can also write h of x. So it is a way to represent a polynomial. Now, look at the highest degree. This is the highest term n. So this is called as a polynomial of degree n. Now, depending upon the degree, the polynomial is classified. So, next topic of our discussion is classification of polynomial. Classification of polynomial. Now, if the degree is 1, then we called it as a linear polynomial. Linear polynomial. Like 5x plus 7. Here we are concerned about the single variable, not about the double variable or more than one variable. If degree is 2, then we'll know about the quadratic equation. So it is called as a quadratic polynomial. Quadratic polynomial. At the same time, I am writing the general form also. So general form of linear polynomial is ax plus b. Ax plus b. Quadratic polynomial, you can take any example, suppose x square minus 5x plus 6. And general form is, we know it is ax square plus bx plus c, where a not equal to 0. Same way we can write, generally leading term coefficient not be equal to 0. If it is a degree 3, then we call it as a cubic polynomial, like x cube minus 1 or x cube minus 3x square plus 3x minus 1. All these are example of cubic polynomial. So general form is ax cube plus bx square plus cx plus d, where a not equal to 0. If it is 4, then it is a biquadratic. biquadratic polynomial. Biquadratic means quadratic is 2, bi means it is 2. So biquadratic polynomial example, suppose if I take x to the power 4 minus 1. So general form will be equal to ax4 plus bx cube plus cx square plus dx plus e, where a not equal to 0. Leading term we always make sure it should not be equal to 0. And what about the polynomial of degree 0? So we called it as a constant polynomial. Constant polynomial. Like 5. Why 5 is called polynomial? So 5 can be written as 5 into 1 and this can be written as 5 into x to the power 0. So this is a polynomial of degree 0. So it is a constant number, or it will be a scalar. Scalar, you know, it is which is contain only magnitude. So these are the introduction of the polynomial, and we classify the polynomial based on their degree. Clear? Now let us discuss the division algorithm. Division algorithm means it is a process of division, algebraic division. So all of you know how to perform a long division method in algebra. So now for example, I am dividing fx by gx. So this we know called it as a dividend. This we called it as a dividend, and this is divisor. Clear? So the first condition is degree of fx. I am writing the condition here. Degree of fx should be greater than equal to degree of gx. Degree of gx. So you will get some quotient here. So that we represent it as a q of x. Quotient. At the end you will get the remainder. We represent it as a r of x. Now, so if you are performing an algebraic expression divided by another algebraic expression, so all these will be the f expression of x. So that's why we are writing fx, gx, qx and rx. Now the second condition is, what about the degree of remainder? Degree of rx less than equal to degree of gx. So either you will get the remainder as 0 or any non-zero expression or we can say polynomial. Am I clear till this point? That means you are dividing an expression by another, so you get the quotient, we will get the remainder. Now what are the possibilities of remainder? You will get the remainder as 0 or you will get a remainder as a non-zero polynomial. Clear? Now suppose if I divide 10 by 2, your remainder will be 0. Clear? And if I divide 11 by 2, my remainder is 1. So basically in remainder we are getting either 0 or non-zero. Now if remainder is 0, then what we call? We call 2 is a factor of 10. Clear? So same way, if remainder is 0, then we call gx is a factor of fx. Clear? Now, have you in the lower classes, in primary classes, you learn this process? 2, 10. So remainder is 1. So how we check the process? 2 into 5 is equal to 10 plus 1, 11. That means if I multiply these two and we add the remainder, then if it is equal to dividend, we term it as our division is correct. So same way here, fx should be equal to gx into qx plus of rx. So this expression is termed as a complete division algorithm. Now let us discuss first remainder theorem, and I give you an example how the theorem will work. If a polynomial fx is divided by x minus alpha, this is important. It should be a linear polynomial. By x minus alpha, then remainder is equal to f of alpha. That means, if I take you an example, x minus 2 x square minus 5x plus 6 divided by x minus 2. So if I divide it by long division method, then you will get, you know the division, so I am not explaining this. What you get? The remainder as 0. Now this theorem says here x square minus 5x plus 6 is equal to fx. And it is divided by x minus 2. And it is divided by x minus 2. Then the theorem says the remainder will be given by f of alpha. Now equate this, x minus 2 is equal to 0. So what is the value of x? X is equal to 2. Now substitute x is equal to 2 in the given polynomial. So if we substitute f of 2, so you will get 2 square minus 5 into 2 plus 6. 2 2 is 4. Minus 10 plus 10, and this is equal to 0. See? So without performing the long division method, if we equate our divisor to 0, find out the value of the variable, and if you substitute in the given polynomial without performing the long division method, you can directly get the remainder. Clear? That means no need to go for this entire process. Just equate this divisor equal to 0 and substitute in place of the variable in the given polynomial. Compute or simplify, you will get the remainder without actual performing the division. Now let us take one example to explain this. Using remainder theorem, or in some sums it is given like find the remainder without performing the division. So either it is directly stated to you or it is given with without actual division. Find the remainder when on dividing fx by 2x plus 1. 2x plus 1, it is a linear polynomial. So it satisfies the condition of remainder theorem where fx is given as 4x square plus 5x plus 3. So first 2x plus 1 equate this to 0. So we will get x is equal to minus 1 by 2. So what is the remainder theorem? Substitute x is equal to minus 1 by 2 in the given polynomial. So we substitute f of minus 1 by 2. This f of 1 minus 1 by 2 we called it as a value of a polynomial. So this is for your knowledge, this is called as a value of the polynomial at x is equal to minus 1 by 2. So we substitute minus 1 by 2 in place of x. So 4 minus 1 by 2 square plus 5 into minus 1 by 2 plus 3. Clear? So 4 into minus 1 by 2 square, it is equal to 1 by 4 minus 5 by 2 plus 3. 4 and 4 will get cancelled. So you get 1 minus 5 by 2 plus 3. 1 plus 3 is equal to 4 minus 5 by 2. So 4 2 is 8. 8 minus 5 is equal to 3 by 2. So remainder is equal to 3 by 2. Clear? So the steps you need to follow, whatever the divisor is given, equate it to 0 to find out the value of x. Once you get the value of x, substitute that value in place of a variable. Compute or simplify, you will get the remainder. Now, student, next we are going to learn is factor theorem. I can say it is a particular case of remainder theorem. Remainder you can get any value, whether it is 0, 1, 2, whatever. If remainder is 0, then suppose fx x minus x alpha, you are performing a division, here you will get the remainder. So remainder you will get anything, either 0 or non-zero. So these are the part of remainder theorem, what we learned. Now if it is 0, then x minus alpha will become the factor of fx. So what is the statement of factor theorem? If fx is a polynomial and alpha is a real number, then x minus alpha is a factor of fx if f of alpha is equal to 0. If you remember, f of alpha will give us the remainder, and if the remainder is 0, then we term this x minus alpha as a factor of fx. Clear? So non-zero or 0, it is a part of a remainder theorem. If it is 0, then this divisor will become a factor of the given polynomial. Now let us discuss one problem. Why factor theorem? So that x plus 3 and 2x minus 1 are factors of 2x square plus 5x minus 3. So first we represent this polynomial as fx. So fx is equal to 2x square plus 5x minus 3. Now the process we are followed in remainder theorem, that is we equate x plus 3 is equal to 0. So it implies x is equal to minus 3. So find out the value of a polynomial at x is equal to minus 3. That means we replace x by minus 3. So 2 into minus 3 square plus 5 into minus 3 into by minus 3. So minus 3 square 9, 9 2 ja 18 minus 15 minus 3 0. So if f of alpha is equal to 0, recall the factor theorem, if f of alpha is equal to 0, then x minus alpha will become a factor. So we write, since f of minus 3 is equal to 0, it implies x plus 3 is a factor of fx, this polynomial. Clear? Similarly, for the next part, so first we equate 2x minus 1 is equal to 0. It implies x is equal to 1 by 2. Substitute. So f of 1 by 2 is equal to 2 1 by 2 square plus 5 by 2. 5 into 1 by 2, 5 by 2 minus 3. So this is equal to 2 into 1 by 4 plus 5 by 2 minus 3. 2 1 jar, 2 2 jar. So here we will get 1 by 2 plus 5 by 2 minus 3. So 1 by 2 plus 5 by 2 is equal to 6 by 2. 6 by 2 is equal to 3. So 3 minus 3 is equal to 0. Remainder is equal to 0 means it becomes a factor. So we write, since f of 1 by 2 is equal to 0, it implies 2x minus 1 is a factor of fx. Clear? Now we'll take some more example to explain this entire chapter. We'll take different kind of problems. Moving into the next problem, when kx cube plus 9x square plus 4x minus 10 is divided by x plus 1, the remainder is 2. Now here remainder is given as 2. So first we write this as a fx. Let fx is equal to kx cube plus 9x square plus 4x minus 10. Now when it is divided by x plus 1, so what we are doing? We are equating it to 0. So x plus 1 is equal to 0. It implies x is equal to minus 1. So now if you replace x as minus 1, so this will give you the remainder. So f of minus 1 will give you the remainder, and remainder is given as 2. So if you substitute x is equal to minus 1 in this polynomial and you equate it to 0, so we will get an equation of k. So k into minus 1 cube plus 9 into minus 1 square plus 4 into minus 1 minus 10 is equal to 2. Clear? So this will be equal to minus k. Minus 1 cube means minus 1. Minus 1 multiplied by k is minus 1 k. Minus 1 square means 1. So plus 9 minus 4 minus 10 is equal to 2. So minus k is equal to, now we will take this all the term to the other side. So 2 minus 9 plus 4 plus 10. So 10 plus 4, 14. 14 plus 2, 16. 16 minus 9. So 16 minus 9 is equal to 7. So minus k is equal to 7. Therefore k is equal to minus 7. Clear? So here we substitute remainder is given as 2. So we equate f of minus 1 is equal to 2, and then using the remainder theorem we find the value of k. The next problem is, what number must be subtracted from 2x square minus 5x so that the resultant polynomial leaves the remainder 2. Now whether it is subtracted or added. So we consider, let a be subtracted from the given polynomial. Clear? So we are subtracting a. So f of x will become, resultant polynomial will become 5x 2x square minus 5x minus a. Now if the question is given what number must be added, so we write plus a. Is it part, for the first part is clear to everyone? Now the resultant polynomial leaves the remainder 2 when divided by 2x plus 1. Remainder 2, so it is an application of remainder theorem. So in remainder theorem what we do? We equate this divisor to 0 to find out the value of x. So 2x plus 1 is equal to 0, it implies x is equal to minus 1 by 2. So here it is given that f of minus 1 by 2 is equal to, what is the remainder? Remainder is 2, because f of minus 1 by 2 will give you the remainder, and remainder is given as 2. So now we substitute x is equal to minus half in the given polynomial. So 2 into minus 1 by 2 square minus 5 into minus 1 by 2 minus a is equal to 2. Clear? So in place of x we replace minus 1 by 2. So it implies 2 into 1 by 4 minus minus plus 5 by 2 minus a is equal to 2. 2 1 ja, 2 2 ja. So we get 1 by 2 plus 5 by 2 minus a is equal to 2. So 1 by 2 plus 5 by 2, it is equal to 6 by 2. 6 by 2 is equal to 3. So 3 minus a is equal to 2. Therefore a is equal to 1. We are taking this a to other side, so it will become plus a. And if you bring 2 on the other side, it will become minus 2. So 3 minus 2 is equal to 1. So a is equal to 1. So if you subtract 1 from this polynomial, in that case you get the remainder as 2. So same thing you can apply when the question is given what number must be added. So you need to write, in this place you write plus a. Clear? And we apply the remainder theorem. Moving into the next problem, it is given that when divided by x minus 3, so this is the divisor, the polynomials, two polynomials are given and both polynomials leaves the same remainder. That means the question is given, if this polynomial divided by x minus 3, you will get one remainder. Similarly, if this polynomial divided by x minus 3, you will get the polynomial remainder once again. Those two remainders are equal. So we have to find out the value of p. So let us consider this polynomial as f of x. So f of x means x cube minus px square plus x plus 6, and we consider this polynomial as suppose g of x. I told you initially you can consider fx, gx, h of x. So 2x cube minus x square minus p plus 3 into x minus 6. Now in the remainder theorem, what we usually do, we equate divisor to 0. So x minus 3 is equal to 0, x is equal to 3. Now if you replace x by 3, then you will get f of 3 and this will be the remainder. And if you replace x is equal to 3 here, so you will get g of 3. And f of 3 is equal to g of 3 because both the polynomial leaves the same remainder. So now replace x by 3 in both the polynomial. So 3 cube minus, I am replacing first with this polynomial, p into 3 square plus 3 plus 6 is equal to 2 into 3 square minus 3 square minus p plus 3 into 3 minus 6. Check what we have done. We replace 3 in both the polynomials. So this will give the remainder and this will give the remainder, and since the remainder are same, so we are equating these two are equal. 27 minus 9p plus 9 is equal to 3 square 9 to the 18 minus 9 minus 3p. If you multiply these two, so minus 3p minus 9 minus 6. Clear? So now separation of variable, we take the variable that is p on one side, so minus 3p, and this 3p we bring it on other side, so it will become plus 3p. 18 minus 9 minus 9 minus 9 minus 9 minus 18 plus 18 cancel. 27 plus 9, it is equal to 36. When it goes to other side, it will become minus 36 minus 6. So minus 9p plus 3p is equal to 6p is equal to minus 42. Minus minus cancel. So it implies p is equal to 42 by 6. It is equal to 7. Therefore, value of p is equal to 7. Moving into the next problem. So that 2x plus 1 is a factor of 4x cube plus 12x square plus 11x plus 3. So this is the sum based on factor theorem. So factor theorem, you need to show that if the remainder is 0, then we can call it as a factor. So we consider fx is equal to 4x cube plus 12x square plus 11x plus 3. Now the way, again I am repeating the way we did in the remainder theorem. Equate 2x plus 1 is equal to 0. So we will get x is equal to minus 1 by 2. Replace it here. F of minus 1 by 2. So we will get 4 minus 1 by 2 cube plus 12 minus 1 by 2 square plus 11 minus 1 by 2 plus 3. Minus 1 by 8. 1 minus 1 by 2 cube is equal to minus 1 by 8. So you get minus 4 by 8 plus 12 by 4. 1 by 2 square means 1 by 4 minus 11 by 2 plus 3. Clear? 4 1 ja, 4 2 ja, 4 1 ja, 4 3 ja. So we will get here minus 1 by 2, and this term I am writing minus 11 by 2. This is plus 3 and this is plus 3. So you will get plus 6. So minus 1 by 2 minus 11 by 2. It is equal to minus 12 by 2. Minus 12 by 2 means minus 6 plus 6. 0. Clear? So you get 0. So if remainder is 0, then 2x plus 1 will become the factor. So we write, since f of minus 1 by 2 is equal to 0, it implies 2x plus 1 is a factor of fx. Now we need to factorize it completely. So we write 4x cube plus 12x square plus 11x plus 3. How to factorize the cubic term? I already make a small videos on this. Link it is given on the I button. So click on the I button, you'll get the video. So since 2x plus 1 is a factor, so we write 2x plus 1, we leave one space gap and then we write 2x plus 1, 2x plus 1 and 2x plus 1. Clear? The leading term is 4x cube divided by 2x. 4x cube divided by 2x. So we'll get 2x square. Clear? Multiply. So 2 to the 4x cube plus 2x square. Now we are writing 2x square and the polynomial is, in the given polynomial it is 12x square. So we need to adjust with 10x square. Now 10x square divided by 2x, it is equal to plus 5x. We will consider the sign. So if you multiply, you will get 10x square, we already written, plus 5x. Clear? Now I have 5x, in the given polynomial it is 11x, so we need to adjust with plus 6x. Now plus 6x plus divided by 2x, it is equal to 3, so we write plus 3. So now if you multiply, you will get 6x and plus 3. Since last term is matching, so our process is correct. So here we write 2x plus 1, 2x square plus 5x plus 3. Clear? Now this can be factorized further. Now factorize completely means you need to carry out the factorization process till it in its simplest form. So if you factorize this, I am showing it here, 2x square plus 5x plus 3. So here 2 into 3 is 6 and 2 plus 3 is 5. So we write 2x square plus 2x plus 3x plus 3. So from first two we can take 2x common, so you get x plus 1. From the last two we will get 3 common, so you get x plus 1. So your factor will be x plus 1 multiplied by 2x plus 3. You can continue the process here. Since I have this space problems, I am doing it some near the sum and then I am writing the result here. 2x plus 1 multiplied by x plus 1 multiplied by 2x plus 3. Now let us discuss this problem. If 2x plus 1 is a factor of this, factor of this means remainder will be equal to 0. So we write f of x is equal to 6x cube plus 5x square plus ax minus 2. Clear? Now we equate it to 0. So 2x plus 1 is equal to 0. It implies x is equal to minus 1 by 2. So how we write here? We write since 2x plus 1 is a factor of fx, it implies f of minus 1 by 2. Minus 1 by 2 is equal to 0. Because if the remainder is 0, then only it will become the factor. So we equate f of minus 1 by 2 is equal to 0. So now in the given polynomial we substitute x is equal to minus 1 by 2. 6 into minus 1 by 2 cube plus 5 into minus 1 by 2 square plus a into minus 1 by 2 minus 2 is equal to 0. So minus, this will be minus 1 by 8, so minus 6 by 8. This is equal to 1 by 4, so we write plus 5 by 4 minus a by 2 minus 2 is equal to 0. Clear? So a by 2 is equal to, I am taking this term to that side. So minus a by 2 will become plus a by 2. So minus 6 by 8, if you simplify, 2 3 jar, 2 4 jar. So minus 3 by 4 plus 5 by 4 minus 2. Now say minus 3 by 4 plus 5 by 4. It is equal to 2 by 4. 2 by 4 means 1 by 2. So here we write 1 by 2 minus 2. So it is equal to minus 3 by 2. Now these 2 and these 2 will get cancelled. Therefore we will get a is equal to minus 3. Clear? Like in the remainder theorem, it is given that find the value of a when leave the remainder 2. So remainder might be different. But if it becomes 0, then only we can term it as a factor. That's why we are equating it to 0. Let us discuss this problem. X minus 2 is a factor of the expression x cube plus ax square plus bx plus 6. So first the information is given, so we analyze the information and write the condition. So x cube plus ax square plus bx plus 6. X minus 2 is a factor, so we equate x minus 2 is equal to 0. So if we equate x minus 2 is equal to 0, we will get x is equal to 2. So we write, since x minus 2 is factor of fx. What does it mean? It means f of 2 will be equal to 0. F of 2 will be equal to 0. So now substitute 2 here. So 2 cube means 8 plus 2 square means 4. So 4 into a plus 2b plus 6 is equal to 0. Clear? So from here we will get 4a plus 2b plus 6 plus 8, 14 is equal to 0. So if you take 2 common, so you will get 2a plus b is equal to minus 7. So this is the first equation. I hope it is clear to everyone. Now when this expression, that means same expression, is divided by x minus 3, it leaves the remainder 3. That means once you divide this polynomial by x minus 3, in that case you are getting the remainder as 3. So if we equate x minus 3 is equal to 0, you will get x is equal to 3. So from remainder theorem we can say that, so you can write from remainder theorem, we can say that f of 3 is equal to 3. F of 3 is equal to 3. Clear? So now substitute x is equal to 3. So 3 cube means 27. 3 square means 9. So plus 9a plus 3b plus 6 is equal to 0. So 9a plus 3b, 27 plus 6, 33 is equal to 0. Now take common, you can take 3 common. So 3 is equal to minus 11. Now see, we will get 2 equations. We will solve this equation by any method. But in method you are very comfortable with. Solve these 2 equations to find out the value of a and b. So 2a plus b is equal to minus 7. 3a plus b is equal to minus 11. I am eliminating I am going through the solve this problem by elimination method because b is same. So just simply subtracting, it will cancel b. So 2a, so it is equal to minus a is equal to 2a minus 3 is equal to minus a, 11 minus 7 is equal to 4. So therefore a is equal to 4. And use any one of the equation. So suppose from 1 b is equal to minus 7 minus 2a. So we substitute a is equal to 4 here. So minus 7 minus 2 into 4. So minus 7 minus 8. Therefore b is equal to minus 15. So a is equal to 4 and b is equal to minus. Now in some time they add another part. Hence factorize completely. So what you need to do, you need to substitute a is equal to 4, b is equal to minus 15 in the given polynomial and follow the factorize them further. Clear? So this is one of the smallest exercise. In this part we complete this chapter factorization. Complete all the sums from your book. In case of doubt, write in the comment box. I'll solve the problem for you. Thank you.